Alright, welcome to lesson 4.05. We're going to start solving simple radical equations using inverse operations. Let's get started. Alright, so to start off with, we're going to follow through A, B, C, and D here. The only ones you need to actually write out are A, then just follow whatever step B says, write out C, filling in the blank, and no need to write out D, just answer the question. Go ahead and work through it at your own pace. Should take about 5 minutes or so, and then press play and we'll take a look together. Alright, so pretty simply for part A, I want to rewrite this as x to the 1 over 2, since there is of course an index here of 2 that's not written. And that means that we have x to the 1/2 is equal to 6. So when I think about what I have to do to both sides so that I now have an exponent of 1, in other words, so that I have solved for x, I need to somehow multiply 1/2 by 2. And I can do that if I simply raise each side to the power of 2. In other words, if I square both sides. So I'll write out what that would look like. Now notice on the left side, when I am simplifying a base raised to a power raised to another power, I am simply going to multiply the two exponents together. And that's why I chose 2, because 2 times 1/2 will give me 1. And so I am then left with x equals 36. Alright, so what does this mean the inverse operation of square rooting is? Well, notice that we were square rooting x, and then to undo that operation, in other words, for us to be left with x, we had to square both sides. And you can see that very clearly. Squaring undoes the raising of x to the 1/2 power because we multiply the two exponents there, and so we're left with an exponent of 1. So this means the inverse operation of square rooting is squaring. Now, with that being said, does the answer that we came up with, x being equal to 36, satisfy the original equation? And certainly it does. The square root of 36 does equal 6. Alright, so when we're solving radical equations, there are a couple of basic things that we want to do. The first is that we want to isolate the radical which has the variable in it, right? That's what we're trying to solve for, so we want to isolate it. And then we want to perform the inverse operation. Let's just make a quick little diagram of what the inverse operations are. So if our operation, make a little table here, if the operation is square rooting, okay, then the inverse will be squaring. If the operation is cube rooting, then the inverse operation would be raising to the 3rd power, or cubing, so on and so forth. And you can remind yourself of this because you can rewrite each of these radical expressions as an equivalent exponent expression. So I could rewrite this as saying raising something to the 1/2, and this I could rewrite as raising something to the 1/3. And then you can clearly see that then raising whatever that is to the 3rd power or to the 2nd power is going to undo that operation. And then once you've done that, you want to check that your solution satisfies the original equation. So let's just do one more quick example together. Okay, so here's an example. What I'm going to try and solve for is the variable such that when I add 3 to it and take the square root and then subtract 6, I will get 3. So to follow through here, I want to isolate my radical so that I can then perform the inverse operation to both sides. In other words, squaring, since this is square rooting. So first I need to add 6 to both sides, and that will leave me with x plus 3. The square root of x plus 3 is equal to 9. And now I can square both sides. Since the operation here is square rooting, I can square, that's the inverse. And I'll be left with x plus 3 is equal to 81. And now simply subtracting 3 from both sides will leave me with x equals 78. And that is the solution. Now I can go ahead and plug this back in, substitute it back in for x in my original equation. I will get the square root of 81, which is 9, minus 6, which is 3, and so it checks out. All right, I'm going to give you a couple to try here on your own. Here they are. There are 4. The last one you might think you're going to get stuck after you perform that inverse operation, but keep at it. I guarantee that you have all the skills you need to solve for the variable there.